Okay, we're finding the radius of convergence of this function. Infinity, k equals 1, that's an infinity. Somehow. That's not much better. Oh well. 2 to the 5k on 5 to the 2k, x on 3 to the k. So first, since we're doing the ratio thing where we do k plus 1 on the top and k on the bottom, if you know what I mean. So if this has been taught to you before, all my channel is just going through some practice questions. That's all I'm here for. So that's what we're doing. So we need to take the limit k tends to infinity of this, let's call this ak. Yeah, what we need to do is we need to go limit k tends to infinity of the absolute value of a to the k plus 1 on a to the k less than 1. That's what we need to do. So we can rewrite this to make it easier. We can go sum infinity k equals 1 of 2 to the 5k x to the k divided by 5 to the 2k 3 to the k. So all I did here was got rid of these two fractions because they're just being annoying. Yep. Alrighty, so this is limit k tends to infinity. So a to the k plus 1. So we got 2 to the 5 k plus 1. So we just added k plus 1 in there instead of k, x to the k plus 1 divided by 5 to the 2 k plus 1, 3 to the k plus 1. So all I did was replace k with k plus 1. Now it's times. We need to times it by a to the k flipped. So we take the bottom and put it on the top. 5 to the 2k, 3 to the k, divided by 2 to the 5k, x to the k. That's the easiest way to do it. Just flip this and write it there. And then substitute k plus 1 into k and just times it by it. It's a lot easier just to do that every time you do a question. So now, this is crazy to find the limit, right? This is stupid. So what we need to do is we need to split these up and cancel a few things out. So we've got limit, first write the limit, absolute value. This can be broken up into 2 to the 5k, 2 to the 5. So what just happened there is I expanded the brackets, 2 to the 5k plus 5, and then you can split them, so they're timesing. Same here, x to the k, x to the 1. See that? It's a plus here, but now they're timesing. Now this is 5 to the 2k, 5 squared, 3 to the k, 3 times 5, and then just write this, 2 to the 2k, 3 to the k, divided by 2 to the 5k, x to the k. Now look at that. We got x to the k and x to the k. Boom, boom. We got 5 to the 2k, gone. 2 to the 5k, gone. 3 to the k, gone. What's left? This guy, this guy, this guy, and that guy. So we got limit k tends to infinity of what's left. We've got 2 to the 5. We've got an x. We've got a 5 squared, and we've got a 3. So there's no x. So it's literally just the absolute value of x times this number, 2 to the 5 divided by 5 to the 2 times 3, which is 32 on 75. You can put that in your calculator, less than 1. Alright, I'm going to move this up now. Everyone got that? Pause it if you haven't gotten up to that point. Alrighty, so this is what we had. And now, what we do is we take the negative of x, 32 on 75, less than 1, and just x. That's how you deal with absolute values to get the two different intervals, the two different points at the end. You put one as negative and one as positive. So what this leaves us is 32 on 75 greater than negative 1. When you divide by the negative, this sign flips, so it goes from a less than to a greater than, and this changed sign. So we just put this sign over there. And we've dropped an x, the most important bit. Okay, so x is greater than, now, negative 75 on 32. That was just timesing by the 75 and dividing by the 32. Oh, that's all that happened. Now this side, x is less than 75 on 32. There we go. So we know, we can put this up here, let's draw a box. Here we go. So x is less than 75 on 32 and greater than negative 75 on 32. So what's the middle point of this? So we take the interval. We've got 75 on 32. We're just drawing a number line here. We've got 0 and negative 75 on 32. The middle point is 0, isn't it? Because it's just, this is the positive version and this is the negative version of the number. So the interval is actually just this number. Is the radius of convergence. See some of my other questions where 0 isn't actually the center, so it's kind of a bit trickier to see what the radius is.